linear velocity when the string is horizontal, this point C and D. So consider a point mass object of mass m tied to the string of length r and performing a vertical circular motion. Point A is the uppermost position, point B is the lowermost position, and point C and D are, we can say, the arbitrary position but at the horizontal. So at this midpoint also, the two vectors are acting. One is the tension along the string which is directed towards the center, and the another vector its own mg which is acting downward. So we can see that the tension force is perpendicular to this vector mg. So here we can say that this point C and D are the arbitrary points, and the tension force always balances the centripetal force, and this force is used to change the direction of this velocity, and the weight mg vector is used to change the speed of this circular motion. To find the linear velocity at midpoint C or D, we have to use a conservation law of energy. So we have taken these 2 points, uppermost point A and the midpoint C, and we can write the equation as total energy at A is equal to total energy at C. Total energy is a summation of kinetic energy and the potential energy, and therefore we can write the equation as kinetic energy at A plus potential energy at A is equal to kinetic energy at C plus potential energy at C. Now, the object is situated at a distance r from the center, and when the point object is moving from point B to A, so potential energy is equal to 2 mgr, and the kinetic energy we can write down as half mva square plus potential energy at point A as a 2 mgr. Now kinetic energy at point C can be written as half mvc square, where vc is a velocity at point C, and the potential energy at point C, as the point C is at an height r, we can write the potential energy at point C as a mgr. Now rearrange the term, we can get it here, half mgr plus 2 mgr is equal to half mvc square plus mgr. Here we have substituted the value of Va, that is the velocity at the highest point A, and that is always equal to square root of Rg. If we square this square root of Rg, we can write down the Va square as a Gr. Now if you do the addition of this half mgr plus this 2 mgr, we can write down the value as 5 mgr plus half mvc square plus, continuing the equation, 5 by 2 mgr is equal to half mvc square plus mgr. The mgr from right hand side, when it will move to the left hand side, it gets minus over there, and we can write the equation 5 by 2 mgr minus mgr is equal to half mvc square. Just rearrange the term and do the calculation. We get half mvc square is equal to 5 mgr minus 2 mgr upon 2. Do the subtraction and we can get half mvc square is equal to 3 by 2 mgr. Here we can cancel out some common term from left hand side and right hand side. 2 is getting cancelled out, and also the factor m is getting cancelled out from both the side, and we can get the value as Vc square is equal to 3gr, and hence we can write down Vc is equal to square root of 3rg. As the point D is also at the horizontal position, we can write Vc is equal to Vd is equal to square root of 3 rg. So value square root of 3 rg is a linear velocity when the string is horizontal, that is at points C and D.